So this is a brief introduction to R. R is a software which you can find at this address, r/project.org. That will take you to the R project for statistical computing, and as you can see, R is a free software environment for statistical computing and graphics. R also has a decent environment for doing matrix algebra, and this is the reason why I will use R. So if you're planning to follow these lectures on linear algebra, I recommend that you download and install R, or you can use any other software which has matrix features such as MATLAB, for example. I use R not because I think it's the best linear algebra package, but more because it's free. Once you have installed it, it will look something like this. One of the fundamental objects of R is called a vector. A vector basically contains a bunch of numbers. Although vectors in R may contain other things than numbers, we will focus on numbers for now on. To create a vector in R, we use the following notation: x followed by an arrow pointing to the left, created by the less than sign and the dash, which is an assignment operator. It basically tells R that I want to create something called x, and x should be assigned whatever is on the right of that. On the right of the assignment is c, and the c function is what creates the vector. Inside the parentheses are the numbers I want to stick into the vector: 2, 5, and -1. So here I have typed the assignment into R. I hit enter. If I want to check that this worked, I can just type x followed by enter, and R will display the content of my vector. A nice way to create longer vectors without actually typing all the numbers is to use the sequence operator. So if I write like this: x assigned 1, 5, I will get a vector with the numbers 1 through 5. So I type like this, hit enter, x again, and you can see that x is 1, 2, 3, 4, 5. If you want to create more complex sequences, such as sequences where the increase is not necessarily 1, you can use the seq function. Just go to the help or Google the R seq function. Once we have created a vector, we can use a bunch of built-in functions in R. We have the plus, minus, multiplication, and division. After the division, you see the caret, which is used for raising to a power. Then a bunch of functions which are almost self-explanatory. Sum will sum all the elements of the vector. Prod will take the product of all the elements. The average. Length will return how many elements the vector has. The min and the max. The natural logarithm. The exponential function. The square root. Round will round to the nearest integer, while floor will round downwards. For example, I can do sum of x, will sum all the elements. I can do min of x, should be 1. I can do the length of x, which should give me 5, so it has 5 elements. If I create another vector, say y, and I assign that, let's say 3, 2, 7, such that it has the same length. By the way, the up arrow is quite nice if you want to retrieve an old command that you have typed. So I press that twice, then we can just change this to y and check that the length of y is 5 as well. Then I can use the binary operators. Let's just first check that y is what we expect it to be, and x, remember, was this. So if I do x plus y, it will simply sum the elements of x and y element by element. So the first 4 that we find here is the sum of 3 and 1. If I do x multiplied by y, it does the same thing, element by element. So the first element of x times y will be 3 times 1, so that should be 3, then 8. Keep in mind that binary operators, plus, minus, multiplication, and division, they're called binary because they require 2 vectors. They do require vectors to have the same length. For example, if I instead do y from 3 to 6, so it's only containing 4 numbers, and I try to do x plus y or any other binary operator, it's going to tell us that it can't do that. If the shorter vector is a multiple of the longer one, then it can add them. In this example, if I do x from 1 to 6, and I do y as 0 and 1, like this, then I can add them, and the result will be like this. Adding 0 to the first element, 1 to the second, 0 to the third, 1 to the fourth, 0 to the fifth, and 1 to the sixth. Since integers are always a multiple of a vector, you can always use the binary operators if you have an integer on one side. So if I have x, for example, going from 1 to 6, and I do x plus 1, it's simply going to add 1 to every element of x, giving me something from 2 to 7. And in the same way, you can multiply the entire vector by a constant or divide it by a constant. So binary operators, the vectors should have the same length, or you could have a number on one side. Or the less common case, you could have the short vector being a multiple of the long one. Once we have created a vector, we also need to be able to extract elements from a vector. And that's quite simple. We use the square bracket to extract elements. So, for example, if I want to extract the third element of x, I just simply type x bracket 3. If I want to get 2 elements from x, say the third and the fifth element, I do x bracket, then c3, 5. Remember, c3, 5 creates a vector containing 3 and 5. And that's the argument that we send to x bracket. You can use the sequence operator if you want to extract several elements, such as if you want to get the first 5 elements of a vector, you can write x bracket 1 colon 5. Filling a matrix with random numbers is very useful when we do matrix algebra. And R has some features for generating random numbers. First, you have the function runif, which will give you a random number from the uniform distribution, that is, a random number between 0 and 1, each number being equally likely. The number inside the parentheses tells R how many random numbers you would like. So if I type runif10, hit enter, it will give me 10 random numbers, and as you can see, all of them are between 0 and 1. You can also see this number inside the square bracket. That's just to help us with the count. So after 8 comes the 8th number in my vector. If I want to get random numbers, which are not necessarily between 0 and 1, I can also use the runif function. So if I do runif10, 2.5, 5, I get random numbers between 2.5 and 5. The uniform distribution gives you random numbers which are equally likely. You can also get random numbers from the normal or bell-shaped curve by using the RNORM. So that will give you 10 random numbers from the standard normal distribution. And if you want random numbers from a normal distribution with a different expected value and a standard deviation, you also can use the rnorm function. So if you do rnorm 10, 3, 2, you get random numbers with expected value of 3 and a standard deviation of 2. The following is quite useful if you just want to generate a matrix with some numbers. If you do floor runif 10, 0, 10, then you will get 10 random numbers, each one being an integer between 0 and 9, and each number being equally likely. Here I'm doing 50 random numbers, so it looks like this.